Hello friends, today we are going to solve exercise 1.3 of CBSE board NCERT class 12th mathematics. Here question number 1 says that let f is equals to 1, 3, 4 relates to 1, 2, 5 and g is equals to 1, 2, 5 relates to 1, 3 curly bracket b given by f function is equals to curly bracket then round bracket 1, 2, 3, 5, 4, 1 and g is equals to 1, 3, 2, 3, 5, 1. Write down golf. Hence solution for this question. Exercise 1.3. Exercise 1.3. Solution for question number 1 is solution for question number 1. Here f is given that f is equals to curly bracket round bracket 1, 2, 1, 2, 3, 5, 3, 5, 4, 1 and g is given that 1, 3, 2, 3, 5, 1. Then function 1 is equals to 2, g 2 is equals to 3. Therefore gof 1 is equals to 3. Function 3 is equals to 5, g 5 is equals to 1. Therefore gof 3 is equals to 1. Function 4 is equals to 1, g 1 is equals to 3. Gof is equals to 1, 3, 3, 1 and 4, 3. This is our question number 1. Then we moving ahead toward question number 2. Question number 2 says that let f, g and h be function from R to R. Show that f plus g OH is equals to FOH plus GOH. F dot G OH is equals to FOH dot GOH. Then solution for question number 2. So here solution of question number 2. Solution 2. Let here given that f R relates to R, G R relates to R, H R relates to R. Now first one is FOG fog OH X is equals to F plus G H X is equals to function H X plus G H X is equals to FOH X plus GOH X. Therefore 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 F plus GOH is equals to FOH plus GOH. Now second one is F dot G OHX F dot G HX is equals to F HX dot G HX is equals to FOGX dot GOHX. Therefore, F dot GOH is equals to FOH dot GOH. Hence, our question number 2 is completed. Now we are going to have find GOF and fog. GOF and fog if one fx function is equals to mod x and gx is equals to mod 5x minus 2. And second one is 5x is equals to 8x cube and gx is equals to x 1 की power 3. Hence, solution for question number 3 is solution 3. First one is given that fx is equals to fx is equals to mod x gx mod 5x minus 2 is equals to gof x gof fx is equals to g f function x is equals to g mod x is equals to mod 5 x minus 2. b1 fog x is equals to f gx gx is equals to f mod 5x minus 2 is equals to mod 5x minus 2 is equals to 5x minus 2. Second one is given that fx function x is equals to 8x cube and gx is equals to x 1 comma 3 1 upon 3, in which a point gof x is equals to g function x is equals to g 8x cube 8x cube 1 upon 3 is equals to b is equals to fog x is equal to f g x function x 1 by 3 is equals to 8 x 1 by 3 cube is equals to 8x. Hence, this is our question number third. We have completed our question third. Now we are going to moving ahead. Here solution for question number 4. First of all, we see question number 4 says that if fx is equals to 4x plus 3 upon 6x minus 4, where x does not equals to 2 upon 3, show that f of x is equals to x for all x does not equals to 2 upon 3. What is the inverse of f? This is our question number 4. Now we are going to solve our question number 4. Question number 4 solution. Fx is equals to fx plus 3 6 and minus 4, where x does not equals to 2 upon 3. F of x is equals to fx is equals to f 4x plus 3 6x minus 4 . 4 4x plus 3 upon 6x minus 4 plus 3 6 4x plus 3 upon 6x minus 4 minus 4 is equals to 4x plus 3 3 6x minus 4 upon 6x minus 4 6 4x plus 3 minus 4 6x minus 4 6x minus 4 4x plus 3 plus 3 6x minus 4 upon 6 4x plus 3 minus 4x 6x minus 4 is equals to 16x plus 12 plus 18x minus 12 upon 24x plus 18 minus 24x plus 16. After solving this, we get 34x upon 24 plus 18 minus 24 plus 16. We get 34. After solving this, we get only x. Now first part is completed. Now look at b part. Let y is equals to 4x plus 3, 6x minus 4. Therefore, y is equals to y 6x minus 4 is equals to 4x plus 3, or 6s 4y is equals to 4x plus 3, 6xy minus 4x minus 4x, 6xy minus 4, 4x is equals to 4y plus 3, x is equals to 4y plus 3, 6y minus 4. Then g y is equals to f y is equals to 4y plus 3, 6y minus 4. Hence inverse of, therefore inverse of f is f itself. Hence our question number 4 is completed. Now we are going ahead to solve question number 5. Question number 5 says that here question number 5 is state with reason whether following function have increased. First one is function 1 comma 2 comma 3 comma 4 relates to curly bracket 10 with function is equals to curly bracket 1 comma 10 comma 2 comma 10 3 comma 10 comma 4 comma 10 curly bracket close. Second, g is equals to 5 6 7 8 curly bracket relates to curly bracket 1 comma 2 comma 3 comma 4 curly bracket close with g is equals to 5 comma 4 6 comma 3 7 comma 4 8 comma 2 curly bracket close. Third one is h 2 comma 3 comma 4 comma 5 relates to 7 comma 9 comma 11 comma 13 with h is equals to 2 comma 7 3 comma 9 4 comma 11 round bracket close 5 comma 13 round bracket close, then curly bracket close. Now we are going to solve question number 5 of NCERT class 12th mathematics. Here our question number, solution of question number 5. Solution of question number 5. First one, function 2 comma 3 comma 4 2 comma 4 comma 3 comma 4 relates to curly bracket 10 with f is equals to 1 comma 10 comma 2 comma 10 3 comma 10 comma 4 comma 10. F is not 1 1, not 1 1. Since 1 comma 2 comma 3 comma 4 have the same image, have the same image, have the same image. 4. F has no inverse. F has no inverse. Second one, G curly bracket 5 comma 6 relates to 1 comma 2 comma 3 comma 4 with G is equals to curly bracket 5 comma 4 6 comma 3 7 comma 4 8 comma 2 curly bracket close. Here also 5 and 7 have the same image, have the same image 4. Therefore G is not 1 1, not 1 1, not 1 1. Therefore G is not invertible. Therefore G is not invertible. Invertible. Now third one, H 2 comma 3 comma 5 curly bracket relates to 7 and 11 with H is equals to 2 comma 7 3 comma 9 4 comma 11 5 comma 13 curly bracket close. Hence function x1 is equals to function x2, x1 is equals to x2, that is each element of x curly bracket 2 comma 3 comma 4 comma 5 has a unique image in y is equals to 7 comma 9 comma 11 13. Similarly each member of y has a unique pre-image in y is equals to curly bracket 7 comma 9 11 comma 13. Similarly each member of y has a unique pre-image in x. Therefore f is 1 1 and onto. Therefore f is invertible. Hence our question number 5 is completed. Now we are going to move on question number 6. Question number 6 says that show that a function round bracket square bracket minus 1 comma 1 is equals to r given by fx is equals to x upon x plus 2 is 1 1. Find the inverse of the function f minus 1 comma 1 in round bracket, that's range f. Here hint is given that for y is equal belongs to range f comma y is equals to fx is equals to x on x plus 2 for some x in round bracket minus 1 comma 1, that is x is equals to 2y upon 1 minus y. Hence solution for this question. Solution of question number 6. Solution for question number 6. Solution fx1 is x1 upon x1 plus 2, fx2 x2 x2 plus 2, fx1 fx1 is equals to fx2 x1 upon x1 plus 2 is equals to x2 plus 2 x1 x2 plus 2 is equals to x2 x1 plus 2 x1 x2 plus 2 x1 is equals to x1 comma x2 plus 2x2, or 2x1 is equals to 2x2, therefore x1 is equals to x2, therefore f is 1 1. B. Let y is equals to x upon x plus 2, therefore yx plus 2 is equals to x, or yx plus 2y is equals to x, therefore x is equals to 2y, x is equals to 2y upon 1 minus y is equals to g comma y, g bracket I y. F inverse x is equals to g bracket square bracket or round bracket is equals to 2y 1 minus y. Hence our question number 6 is completed. Our question number 6 completed. Now we are going to move on question number 7. Question number 7 says that consider function r relates to r given by fx is equals to 4x plus 3. Show that f is invertible. Find the inverse of f. And solution for question number 7 is solution for question number 7. Solution for question number 7. Solution for question number 7 says that question 7 says that according to question f r relates to r given by fx is equals to 4x plus 3, function x1 is equals to 4x1 plus 3, function x2 is equals to 4x2 plus 3. If fx1 if x1 is equals to fx2, then 4x1 plus 3 is equals to 4x2 plus 3, or 4x1 is equals to 4x2, therefore x1 is equals to x2, therefore f is 1 1. Also let y is equals to 4x plus 3, or 4x is equals to y minus 3, x is equals to y minus 3 upon 4 for each value of y. value of y belongs to R and belonging to codomain. Y has a preimage. Y has a preimage in its domain. Preimage preimage in its domain. Therefore, f is onto. F is onto. That is, f is 1 1 and onto. Therefore, f is invertible. Invertible. F inverse y is equals to gy. G bracket round bracket y is equals to y minus 3 upon 4. Here our question number 7 is completed. Now we are going to move on question number 8. Question number 8 says that consider function r positive relates to 4 comma infinite given y fx is equals to x square plus 4. Show that f is invertible with the inverse f inverse of f given by the f inverse y is equals to under root y minus 4, where r is the set of all non-negative real numbers. Hence solution for question number 8. Question number 8 says that solution of question number 8 solution of question number 8, f x1 is equals to x1 square plus 4 and x2 square plus 4. Fx1 is equals to fx2. Therefore, x1 square plus 4 is equals to x2 square plus 4, or x1 square is equals to x2 square. Therefore, x1 is equals to x2. As x belongs to R, therefore x is greater than 0. Therefore, f is 1 1. F is 1 1. F is 1 1. Let let y is equals to x square plus 4, or x square is equals to y minus 4, or x plus x is equals to plus minus y minus 4. Now x being is greater than 0, negative sign not to be taken. Therefore, x is equals to y minus 4. Therefore, f inverse y is equals to gy is equals to y minus 4, comma y is greater than 4 or equal to 4. For every y is greater than equal to 4, gy has real positive value. Therefore, the inverse of f is f inverse x. F inverse y is equals to under root y minus 4. Now we are going to move on question number 9. Question number 9 says that, here is the question number 9. Question number 9 says that consider f function r बेस में पॉजिटिव relates to minus 5 comma infinite given by fx function x is equals to 9x square plus 6x minus 5. Show that f is invertible with function f inverse y is equals to under root y plus 6 minus y round bracket upon 3. And solution for question number 9 says that let y be an arbitrary element in range of f. Let y is equals to 9x square plus 6x minus 5 is equals to 9x square plus 6x plus 1 is minus 6 minus 6 is equals to 3x plus 1 का whole square minus 6 y plus 6 is equals to 3x plus 1 का whole square और 3x plus 1 is equals to y plus x 6. Therefore x is equals to y plus 6 minus 1 upon 3 is equals to g comma bracket square bracket or round bracket y. Let g range f relates to r positive such that g round bracket y plus x minus 1 upon 3 of x is equals to g fx is equals to g 9x square plus 6x minus 6. Hence our is equals to g 3x plus 1 का whole square minus 6 round bracket under root 3x plus 1 का whole square minus 6 plus 6 round bracket minus 1 upon 3 3x plus 1 minus 1 upon 3 is equals to x. Therefore of x is equals to x. Now fog y is equals to fgy fy plus 6 upon 3 minus 1 3 y plus 6 minus 1 upon 3 plus 1 bracket whole square minus 6 is equals to y. Fog y is equals to y. Therefore gof is equals to gof I base x fog I base y. Therefore f is invertible. Therefore f inverse y is equals to under root y plus 6 minus 1 upon 3. Now we are going to solve question number 10. Our question number says that let function x relates to y be an invertible function show that f has a unique inverse. So solution for question number 10 is if f is invertible if f is invertible go x is equals to I base x and fog y is equals to I base y. Therefore f is 1 1 and onto let there be two integers let there be two inverses g1 and g2. Therefore fog 1y is equals to I base y and fog 2 bracket y is equals to I base y. I base y. Here I base y being unique for a given function f. Therefore g1 round bracket y is equals to g2 y. Because f is 1 1 and onto, therefore f has unique inverse. Now we are going to solve question number 11. Consider f curly bracket 1 comma 2 comma 3 is equals to curly bracket a comma b comma c given by function 1 is equals to a, function 2 is equals to b, and function 3 is equals to c. Find f inverse and show that the f inverse bracket whole inverse is equals to f. And solution for question number 11 is function 1 comma 3 a comma b comma c show that f1 is equals to a, f2 is equals to b, comma f3 is equals to c. Now let x is equals to a1 comma 2 comma 3, y is equals to a comma b comma c. Therefore f x relates to y, f relates to y. Therefore f inverse y relates to x such that f inverse 1 f inverse b is equals to 2, f inverse c is equals to 3. Inverse of this function may be written as f inverse inverse x relates to y such that f inverse का whole inverse 1 is equals to a, f inverse का whole inverse 2 is equals to b, and f inverse का whole inverse 3 bracket 3 is equals to c. We also have function x relates to y such that f function 1 is equals to a, function 2 is equals to b, function 3 is equals to c. Therefore we also have f function x relates to y such that f1 is equals to a, f2 is equals to b, f3 is equals to c. Then f inverse का whole inverse is equals to f. So our solution of question number 11th is also completed. Now we are going to move on question number 12. Question number 12 says that let function x relates to y be an invertible function so that inverse of f inverse is f, that is f inverse the whole inverse is equals to f. Hence question number 12 is solution for question number 12. Solution of question number 12. Question number 12. F x relates to y is an invertible function. In invertible function, therefore f is 1 1, f is 1 1, and onto g y relates to x, where g is also 1 1, g is also 1 1, and onto such that gof x is equals to I base x and fog I base y is equals to g is equals to f inverse. Now f inverse o, f inverse का inverse is equals to I, and f inverse o, f inverse whole y is equals to foi, or fof of inverse o, f inverse का whole inverse is equals to f IO f inverse IO f inverse का whole inverse is equals to f. Therefore f inverse का whole inverse is equals to f. -1 into -1 करेंगे तो इसका पॉजिटिव आ जाएगा, +1. Hence this is our required answer. This is solution number 4. Solution number 12. We have completed our question number 12. Now we are going to move on question number 13. Question number 13 says that if function r relates to r be given by the fx is equals to 3 minus x cube का whole round bracket 1/3, then f of x is equals to, here option is given. Option says that x की power 1/3, b x cube, c x, d 3 minus x cube. And solution of question number 13. Solution for question number 13. Question number 13, if function r relates to r defined by fx is equals to 3 minus x cube whole power 1 upon 3. First of all, we are going to find f of x is equals to function fx is equals to function 3 minus x cube whole bracket 1 upon 3 and our square bracket or round bracket closed. After that we get curly bracket 3 minus x cube whole power 1 upon 3, then curly bracket close and also square bracket, big square bracket, bada wala round bracket also closed, and the whole power is 1 upon 3. First of all, according to rule BODMAS, we are going to solve bracket. First of all, we are going to solve bracket, then 3 into 1 upon 3 is equals to 1, and then we are moving ahead. After solving we get round bracket 3 minus 3 minus x cube 1 upon 3 is equals to x cube 1 upon 3 is equals to x. Hence our part C is our correct answer. Part C is our correct answer. Correct answer. Here part C is equals to x. That is correct answer. Now next question is question number 14. Let function r minus curly bracket minus 4 upon 3 is equals to r be a function defined as fx is equals to 4x upon 3x plus 4. The inverse of f is the map G. Range f relates to r minus curly bracket minus 4 upon 3 given by. Here solution for question number 14. There is an option. First of all, we are going to read option. Option A says that G round bracket y is equals to 3y upon 3 minus 4y. B is given that G y is equals to 4y upon 4 minus 3y. C given that G y square bracket close is equals to 4y upon 3 minus 4y. D given to us G round bracket or square bracket y is equals to 3y upon 4 minus 3y. This is our last question. So after solving this, we are going to move on next exercise, that is exercise 1.4. So solution for question number 14. Solution of question number 14. Solution for question number 14. Let f function r minus round bracket minus 4 upon 3 relates to r be a function defined as fx is equals to 4x upon 3x plus 4 comma x belongs to minus 4 upon 3. The inverse of f is map G. Range f relates to r minus curly bracket minus 4 upon 3 is given by. Hence solution for this is function r minus 4 upon 3 relates to r is a function defined by fx is equals to 4x 3x plus 4. Let y is equals to 4x 3x minus 4, 3x minus 4. Therefore 3x plus y 3x plus sorry 3xy plus 4y is equals to 4x or x. After solving this, after taking x as a common, 4 minus y is a residue is equals to 4y. Therefore x is equals to 4y 4 minus 3y. Therefore f inverse y is equals to gy is equals to 4y upon 4 minus 3y. Hence part B is the correct answer. Hence we have completed our exercise 1.3 exercise 1.3 of NCERT class 12th mathematics solution. We have solved our all question. Next we are going on exercise number 1.4. Here these examples are given for exercise 1.4. So इसको सॉल्व कर लेना. एग्जाम्पल जितने सारे दिए हैं, एग्जाम्पल सॉल्व करने के बाद I am going to move direct on exercise 1.4. Here question number 1 says that determine whether or not each of the definition of star given below gives a binary operation. In the event that is this symbol is not a binary operation, give justification for this. So this exercise is totally based on binary operation. Now here part 1 is given that on z positive, here z is integer, define symbol by symbol of star or asterisk. A into b is equals to a minus b. Here we are going to move on our question number 1 for solution of exercise 1.4. 1.4 exercise 1.4 exercise 1.4 solution 1 says that if a is greater than b and a into b is equals to a minus b is greater than 0, which belongs to z positive. But if a is less than b and a into b is equals to a minus b, then 0 is greater than a minus b, which does not belongs to z positive. Therefore asterisk given operation is not a binary operation. A binary operation. Now second part, for all A and B belonging to Z positive, AB also belongs to Z positive. Therefore, therefore here belonging to Z positive. Therefore, the operation, the symbol defined by A into B is equals to AB is a binary operation. Binary operation. Now third one is for all A and B belonging to R. AB square also belongs to R. Therefore, the operation asterisk or star defined by A into B. A into B is equals to AB square is a binary operation. Binary operation. Now question number 1 part 4, for all A and B belonging to AB square also belongs for also A and B belonging to Z positive mod A minus B is a binary operation. Now our part 4 is also completed. Here part 4 completed. Part 5 on Z positive defined by asterisk by A into B is equals to A. Hence solution for question number 1 part 5 on Z positive defined by A into B is equals to A comma B belongs to Z positive. A belongs to Z positive. Therefore, star is a binary operation. Now we have completed our part 1 question number 1 of exercise 1.4 NCERT class 12th मैथमेटिक्स. अभी तक आप चैनल को सब्सक्राइब नहीं किए हैं तो चैनल को सब्सक्राइब कर लें. प्लीज़ सब्सक्राइब माय चैनल and be a part of our channel that is dedicated toward PCM subject physics, chemistry, maths. Here अभी NCERT चालू है. NCERT के बाद NCERT पूरी ख़त्म करेंगे. उसके बाद हर एक चैप्टर के आपको सॉल्यूशन देखने को मिलेंगे. हर एक क्वेश्चन के कोई क्वेश्चन छूटेगा नहीं. NCERT totally based. These lectures are totally based for board exam class 12th and also for future reference. So हम लोग मिलेंगे अगली वीडियो में. अब अभी तक आप चैनल को सब्सक्राइब नहीं किए हैं, चैनल को सब्सक्राइब कर लें, दोस्तों के साथ शेयर कर दें और प्रेस नोटिफिकेशन बेल ऑन. अपने दोस्तों के साथ शेयर करने के बाद चैनल को आप भी लाइक करें, शेयर करें, सब्सक्राइब करें। थैंक यू एवरीवन। धन्यवाद। थैंक यू एज वेल।